Let's start at the beginning and talk about design patterns and who the heck are the Gang of Four. Many years ago, I went to a course about designing software. This was back in the Windows 3.1 days, and Windows had a tremendous selection of colors. It had black and white and gray. It also had certain important design standards. The File menu was on the left, the Help menu was on the right. It also had some other standards. The OK button was on the left, the Cancel button was on the right, at the bottom of the screen. And if you think back to those old Windows apps, if you've ever seen one, they're really pretty simple and they follow very simple basic patterns. But yet the first line of the course was Designing Software is Hard. And they showed all sorts of examples of people who had messed up usability in Windows 3.1 apps. Well, since that time, we've had the web. And the web broke all of those interesting user interface design rules that I had learned. It used colors. And Mac and Windows can't agree as to which side the OK button should be on, and websites can't agree either. So now we have design patterns. And design patterns aren't used particularly for user interface designs. I use that as an example. Designing reusable object-oriented software is also hard. As software has grown in complexity, it's also gotten harder to write good software. Design patterns help us write good software because what we're going to be using are patterns that have demonstrated a proven success over the years. So our software designs should address our immediate problem, obviously. We hope that they should also be flexible for future problems, or expansions, or features, or at least they won't inhibit those future expansions because we've designed ourselves into a box. We would also like to reuse things that have been proven to work. And these are the patterns that we're talking about. They're effectively building blocks of code. Now, we're not talking about copying and pasting our favorite pieces of code. We're talking about the patterns that build that kind of successful code. And we don't really need to reinvent the wheel. If someone has created a pattern that solves a problem that we have, then we don't really need to create our own solution, unless, of course, their pattern just isn't any good. The design patterns that we're going to talk about in this course have been proven over time, and they also solve really common architecture problems in software. A pattern addresses a common problem. So if we have, for instance, a problem that we have complex objects to create, and we don't want to spread all of that complex construction all over our application, that's a pattern. It's called the builder pattern, and we'll be taking a look at it. It's a template or a guide. It's not a final design. So when I talk about a builder pattern, we're going to be talking in general terms. We'll give you concrete examples, but the builder pattern can be applied to all sorts of different kinds of software. It can be applied to mobile. It can be applied to web or desktop. It can be applied to different languages as well. We're going to focus on C#, but these patterns were written prior to the existence of C#. They're really design patterns as opposed to language patterns. We're going to do some C# implementations of those patterns, but the ideas behind the patterns are the same. The pattern doesn't describe classes. It actually describes relationships, interactions between classes. The classes that you create are going to be particular to the application that you're creating. You may have customer classes. You may have measurement classes or graph classes or document classes. Patterns don't talk about those kinds of things and the specifics within the classes. It talks about how the classes relate and work with each other. The patterns aren't architectural either, so it's not an entire application architecture. For instance, you might be familiar with three-tier architecture or MVC architecture. The patterns that we're going to talk about in design patterns are smaller in scope than that. They're actually little pieces of that overall architecture. Now, later on in the course, we will talk about more global architecture issues as well, and including we'll spend some time on MVC. A design pattern has 4 elements. It has a name. I hope that's self-explanatory. It also describes the problem to be addressed. And when we talk about each one of these patterns, we're going to start with what's the problem, because that's really what's going to happen in your practical usage. You're going to be presented with an application or part of an application that you have to build.